of the client-server split and is moving into another area that I've labeled initial connection and logon. This, again, in sort of a description, is an interesting area because what I'm going to cover here is sort of the process that happens from when a box first comes from a manufacturer until to the point where it's in the customer home, they're just using it on a day-to-day basis. There's a lot of detail here. Please sort of interrupt me and stop me as you have questions as I go. It's, I think, important to understand the process because we help deploy this to customers and set it up. They need to have some understanding on which parts we're responsible for, which parts they're responsible for, how the process works, what the security is involved with it. It ties in somewhat to what Mike was talking about on the provisioning earlier, and I'll point out places where we start talking with the database. But this sort of covers the whole flow scenario of what happens. Again, it may not directly applicable to what you're doing. I think it's a useful background to understand what's happening on this. So in the first thing happens is a customer is going to call their customer service rep and say, I'd like to get this new top box. I've heard great things about it. Please give me some. And at that point, they're going to talk with customer service rep. They're going to give their name and address and billing information and data like that. And customer service rep is going to create an entry in the database that includes a work order number associated with that new customer. This will go through some of the stuff that Mike was talking about. We'll provision the billing system. It will get into our service and any other people that need to get the information at this point. So at this point within our database, we have a record of other people may have records in their databases depending on how it's set up. But this is being done over the telephone by the customer service rep. Next thing that happens, a technician is going to go out to the customer's home with the set-top box and the work order number. And he's going to set up that set-top box in the customer's home, fix up the RF cables in the customer's home because inevitably they have all sorts of splitters and they have bad signals on it. So almost basically, my understanding is that all of our current customers are planning on the truck roll because they believe that the cable infrastructure in the customer's home is almost never correct for what they're trying to set up. He will, at this point, pull a set-top box out of his truck and notice it's any random set-top box. Up until this point, you don't know which box that customer is actually going to get. At this point, he takes the top box from the stack, he's gone into the home, he's cleaned up the RF things, and he goes ahead and turns it on. At this point, the set-top box is going to power up, it's going to talk over the radio frequency coax cable to the CMTS hub, and it's going to go through DOCSIS protocol of coming up. That will include some low-level RF stuff, and it gets to the point where now it's able to talk IP traffic. At that point, it's going to send a DHCP request looking for an IP address. It will come down to the DHCP server associated with that MTS, and will return an IP address to the set-top box. At this point, the set-top box is up and running and is available to talk to other people on the net. Yes, Dan? CMTS is the cable modem termination system. It is a box that is in the cable operator's head end, and what it does is it mixes IP traffic and video traffic and sends it out to the customer. So that's the point at which you would be merging video streams and IP traffic out to customers' home. And DOCSIS is one of the two competing protocols for talking to CMTS from a cable modem to a CMTS. The other protocol is DVB-C, I think, which is also known as DAVIC, which is the European standard. All PC is actually using DOCSIS. So DOCSIS is way further along than the DAVIC/DVB-C, but Europeans trying to force that as another standard. So from our point of view, we actually don't care, because what we care is that the from the server point of view, we don't care. The client cares, the cable modem. From our point of view, though, all we care is that the client comes up, gets an IP address, and talk with us. So right now, the client, the set-top box, is up at the point it has an IP address and it can start talking with people. The first thing it's going...
Sorry, the cable modem is inside the FTD.
Yeah, the set-top box has a cable modem into it, but that's actually not required. I mean, different manufacturers might make it so it's an external cable modem. We don't really care. There's a cable modem in a set-top box, and often they're integrated. In DCT 5000, they are. So at this point, the set-top box is going to go and talk with a new box service. This is part of where it's a little bit fuzzy because it depends on what the customer wants. That new box service may be part of the hub provided by the MTS vendor, so Cisco's C-Source software. It may be done by a third party, so at home for AT&T would like this. Or it may be that we run that new box service in our TV server. We're flexible on when it happens, where it happens, but in talking with customers, it's important that someone has to do this. This is the first place a box talks to when it first powers up, and that's going to present a UI that allows the technician to enter the work order number. This new box service, because it's being talked to by the box, knows the ID of the box. So that each box has a unique ID. It may be its MAC address, it may be a silicon serial number burnt into the box, but somehow or another each box has a unique address or a unique ID that's presented to this new box service and is presented in general talking with TVPAC server. So we enter the work order number, the box ID we know, and then based on that work order number, which was saved when we first created the customer database record, we can go ahead, look up that customer entry, and now add box ID to that database entry. So now we know which box that customer is using. And that's important later on because that box ID identifies that box for a lot of other things. If the new box service was in the hub, there would probably be a database associated with that hub where it was, for instance, only giving out valid IP addresses to people that were within its database. That's one thing that you may or may not want to do. In that case, the new box service here would have to call through some of the provisioning APIs that Mike talked about to TV server to add that box ID to the database. If we're running the box service in TV server and there was that database in here, again, we would need to call out through a SO to this. Or a customer might not have a separate database associated with hub. It's really one of these flexible things on how they're wanting to sell it up. This is hardware that they're buying from Cisco or 3Com, and they're needing to make some decisions with them on how to set it up and run the service.
And this one point, so the box ID isn't a silicon number. Is it software that's handled by TVPAC client?
MSTV client needs to provide a unique identifier. That unique identifier, if it's burnt into the box, is something that we call a silicon serial number. With the DCT5000, my understanding is there's no way to burn something unique into each box. However, each box has to have a unique MAC address. That's required by the TCP/IP networking protocol. So in that case, you would probably use the MAC address as the box ID. From MSTV server, we really don't care. It just has to be some unique number. My best guess is that with DCT5000, that's going to be the MAC address. Smart card could be an option, and that provides the unique address, and then that becomes associated with it. So that would allow users to travel with a card that identifies them. It's something that is going to be used to tie to the subscriber in the database. So from here, the new box service is going to redirect the set-top box to our pre-registration server. This is the first point at which we actually know we're talking with the TV server. New box service might have been or not have been, whatever, but here we're finally connecting to the TV server. So when the top box is connecting to pre-reg, it's going to go ahead and provide its box ID. Pre-reg will then look up that user and who it is going to pick an initial shared secret and list of head waiters and send that back to the set-top box, and at the same time will save that initial shared secret in the database record associated with that user. So at this point, we now have a unique key in the set-top box and a unique key that the server knows about in the database, and that is over an SSL connection because we don't have any other way of setting it up at that point. So we do it over SSL, it's secure, and we now have the initial key that's shared between the two.
Mark, the head waiter list, what exactly do you mean by head waiter list?
So, I'll get to that on the very next step. The other thing that happens is this is the first point at which the user, rather than the technician, is starting to use the box. This is where we're going into a UI that's asking the user, what would be the email address or the account name that you want for yourself. Because we didn't force that to happen at the customer call. We want to give the user the option. Of course, they're going to try some names that are already being used. We can present alternatives, etc. This is where we actually get that, and we'll put that in the database also. At this point, the database is fully provisioned. We know for that user all of their address information, billing information, the box ID associated with them, and the account name they need and using. This is also the point where we would use our general provisioning scope to talk with the mail backend to make sure they can actually create an account in that mail backend that can be used with that username. So I'm not really going to be talking about mail at this meeting, but we do have multiple mail backends, so you need to communicate with it to create the account on the back end. The box at this point, and I've indicated line, is fully provisioned. The next steps I'm going through are a set of steps that will happen in the future anytime someone powers on that box. And what's going to happen is, at this point, you're going to want to talk with head waiter, or one of multiple head waiters for redundancy. So the box will go ahead and communicate with head waiter, and because we gave it a list of head waiters, if one of those head waiters is down, it could actually go to alternate head waiter. And this is the initial connection point when someone is trying to log into TV server. So the set-top box will go to head waiter, it will send its box ID, and then start encrypting the connection based on its initial shared secret. Based on the box ID, you can look up that shared secret so we know what it is in the server and start the two-way authentication over that encrypted link. At this point, we know it's a real box. They can talk with us. And even if someone sent out the wrong box ID because they tried to clone it, they don't know the shared secret. When they tried to communicate, we're just going to see garbage and vice versa. So this is both the box ID and the shared secret are what guarantee that it really is the box that we know about, and when they're talking with us, that they really know it's one of our authorized head waiters. At this point is where you get the UI that will ask you to select which user do you want to log in as if you have multiple users associated with that box, and also then what password, the password associated with that account. Again, if you only have one user on the box with no password, these two steps are skipped and you go directly, you bypass them entirely. And that's where head waiter then at this point knows which user on that box. So initially it just did the box. Now it knows the actual specific user that's logged in. And it can generate 4 pieces of information. One is a set of session keys. These are what will be used for all further encryption. Another is the ticket that I talked about earlier. So this is the name of that user and the capabilities of the user. A server list, which I'll talk about in a little more detail, and then the initial home service. The server list is similar to what I talked about when I said a head waiter list. And at this point, you gave them a list that was really short. It had head waiter and then several head waiters to go to. At this point, the server list actually has for each service that we have as part of MTV server a list of servers that will provide that service. So this may have home page with a couple servers, mail with a couple servers, favorites with a couple servers. This is what we then use again for the availability and scalability purposes. And then the initial home service. So at this point, the box has all of this information. It's got it from head waiter, and then it will go to its initial home service. So I've indicated that as WTV Home is the initial home service perhaps this box has. And when it connects to that initial home service, which it got from the service list, so if that particular server that was serving happened to be down and fail over to another server on that server list associated with that particular service it was trying to use, it will go ahead, send its ticket, and then start encrypting with the session keys that provided to it from head waiter. The service that it's talking with will read in the ticket. It will decrypt that ticket with the service key. So each ticket is encrypted with the service key that's known to all the services but not the client. So the service, in this case WTV Home, can decrypt the ticket. It will pull the session keys out of the ticket that was assigned to that user. Now you can start the lightweight two-way authentication. You know who the user is. You also know, you know that it's a valid user. You've encrypted it, and you know who it is based on the information in the ticket. The thing that's interesting about these two steps is this is what you repeat through any time you're using any other service. Mail, favorites, whatever. You go back, you first connect to it, you send out your ticket, and then you start encrypting with your session keys. The service that you're talking with will unpack the ticket, read the session keys, and communicate back with you, and also knows which user you are. So these are the steps you go through. You talk with different services within the TVPAC server. So that was a whole lot of steps, and I went through it without stopping. So if you have questions, feel free to ask. It's sort of a lot of technical detail, but I wanted to give you an idea of the process that went through. At this point, we know what we're doing when we talk with any other service. And as I said, anytime you go ahead and turn the power on the box again, it will restart at step 8, get a new set of tickets, select which user you're logging in as, send out the stuff, and repeat through these steps. So it gives you a general idea of what's going on. It also gives you an idea from the earlier set of steps 1 through 7, some of the work that needs to be done with the vendors on the CMTS and through the provisioning steps. I glossed over a lot of the database interface, but that was covered by Mike earlier, where you're provisioning multiple different systems and billing interfaces and things like that. So, questions?
Maybe I suggest and touch on when the cable model, whether the TV home and the web home are integrated on one page, and we go through all these steps.
So I think the question that was brought up before is what's happening as you start to integrate web home and TV home. And I think the answer is the same I gave before, which is it's a UI question. We could support almost anything. At some point, obviously, you will want to authenticate the user, almost certainly before you let them send or receive mail, quite likely when they're accessing their favorites. You may want to do it before you let them do any web browsing at all. Certainly, if you have a household, you have some restricted account and some unrestricted, it would be unwise to let the household account be totally unrestricted. If someone's setting up like there's just the mall and there's nothing else but the mall and no one can go outside the mall, then certainly I would expect that you would allow general browsing in the mall at any time. But maybe you would require that if some users had unrestricted access and they tried to go there, it would bring up something saying, please log in as one, or present your user ID to go out to the mall. So we have quite a bit of flexibility on that. But the real thing is I think this is a big unknown area. I don't think people have actually explored a lot with what to do with this. We certainly on the development side are looking at some various scenarios and will probably present a combined user web home integrated homepage as an initial place that people could start with. But it's something that I expect that different operators, as they work through, may want to make some changes to. Yep. There is nothing in our service that would prevent you from logging in from 2 boxes on the same time. Note, however, that our service is set up that the only people who can log on to a given box are the people who are associated with that box ID. So you couldn't go over to your friend's house and log in on their box because we actually present a whole lot of the security physical possession of the box. But if you had 2 boxes in your own household, one upstairs and one downstairs, and it had been set up so that you had accounts on both, you could certainly go and log into both at the same time. However, this again brings up some of the UI things you may run into. If an MSO wants to enable that capability, we have to say, okay, if a user goes to their mail and upstairs and downstairs, 2 people are logged in as the same user on the same mail account, one person deletes a message and another one tries to read that message, they may get an error message like, that mail message is no longer available, sorry. I mean, that's sort of a UI type thing that we can't do much about. So there are some interesting cases that happen with that. If one person is manipulating the favorites list while the other person is in the middle of using it, it's not well defined even what you should do in those cases. So our only guarantee is we will try and do something reasonable. The box won't crash. They may get some error messages that are not intuitively obvious to them without thinking through, oh, my husband just deleted the message I was trying to read. So we do expect that might generate some calls to customer care. But on the other hand, I'm not sure, if you really had 2 people in the household in 2 boxes, why would they both be logged in as the same user on the same time? So we could prevent it if people didn't like what they got, but we could also enable it.
You meant smart cards, though, too. You could have the physical smart card, not
Right.
necessarily in the box.
Yeah, I'm not sure that our 1.0 release is going to support smart cards because I'm not sure the capabilities with the DCT-5000s. Yes, if your physical manifestation of yours was a smart card, then you just go and plug into whatever box you're in. Certainly a model we'd like to get to, and just I'm not sure what the status is on that.
Does the server actually care about smart cards?
No. I mean, it would care in that we would have to be recognizing both box ID and the smart card ID and care, but it's not a huge difference. Server, it's like, okay, well, it's another entry in the database. Questions?
Are there any export restrictions on any of these?
Yes. The current encryption that we use, I described as 128-bit RC4 encryption. TV Pack server as it ships standardly comes with 40-bit, which is available for export with an upgrade product that gives you 128-bit. We believe in talking with the NSA that we will be able to let UPC use this without any problems because they have American-based owners. In general, though, for sales overseas, this is a problem and would need to either get a separate license for 120. I mean, they could get the 40-bit, no problem. If they want the 128-bit, that needs to be worked out in individual license. We're hoping some of the stuff that we've read about in the papers about relaxing these restrictions would make it go away. We do have the capability of shipping the 40-bit, that's standard default, and you actually need to do an upgrade on U.S. Cable operators. Other questions? Perfect. Well, we're about 10 minutes behind, so I'll let the next person go.